Okay, so yesterday we talked about inductive reasoning. That's just making generalizations from patterns. You can't really determine why it's true. You're just kind of following a pattern. So have you ever noticed that the days are longer in the summer, or that mosquitoes appear after a summer rain? Over the years, you have made these conjectures using inductive reasoning based on patterns you have observed. When you make a conjecture, the process of discovery may not always help explain why the conjecture works. You need another kind of reasoning to help answer this question. So deductive reasoning is the process of showing that certain statements follow logically from agreed upon assumptions and proven facts. When you use deductive reasoning, you try to reason in an orderly way to convince yourself or someone else that your conclusion is valid. If your initial statements are true and you give a logical argument, then you have shown that your conclusion is true. For example, in a trial, lawyers use deductive arguments to show how the evidence that they present proves their case. A lawyer might make a very good argument, but first the court must believe the evidence and accept it as true. You use deductive reasoning in algebra. When you provide a reason for the step in the process of solving an equation, you are using deductive reasoning. Here's an example. If we wanted to solve this equation for x, we'll give a reason for each step in the process. So here's our equation: 3 times the quantity 2x plus 1 plus 2 times the quantity 2x plus 1 plus 7 equals 42 minus 5x. So that was given to us. Then we would know to solve this for x, we would have to distribute. So when we distribute, we get 6x plus 3 plus 4x plus 2 plus 7 equals 42 minus 5x. Then we need to combine our like terms. We can combine 6x plus 4x to get 10x, and 3 plus 2 plus 7 to get 12 on the left. That equals 42 minus 5x. Then we have 15x plus 12 equals 42. All we did was add 5x to both sides. That's the addition property of equality when you add the same thing to both sides. Then we had to subtract 12. So we get 15x equals 30. That's the subtraction property of equality. When you divide by 15 on both sides, x equals 2. That's the division property of equality. Okay, so in this example, here we have a diagram. Ray AC bisects the obtuse angle BAD. So we want to see if angle BAD, angle DAC, and angle CAB are acute, right, or obtuse. And then we'll complete the conjecture. So angle BAD in all of these cases was obtuse. All of these angles are bigger than 90. If you look at angle DAC and CAB, well, if this is bisected, that means each of these angles would be 60 degrees if we cut it in half. If we take 158 and divide it by 2, we'd be at 79 degrees for these two angles. And if we take 92 and divide it by 2, we get 46 degrees for each angle. So in each case, angle DAC and angle CAB are acute. So if an obtuse angle is bisected, then the two new congruent angles are acute. So that's our conjecture. That's the pattern that we see. That was using inductive reasoning. Now we're going to use deductive reasoning to explain it. Okay, so we took the angle bisector of each angle. That splits an angle in half. To start, an obtuse angle is more than 90 degrees, but it has to be less than 180 degrees. So the new angles that we made when we bisected are less than 90 over 2, or 45 degrees. Or sorry, are more than 45 degrees, but they have to be less than 180 divided by 2. They have to be less than 90. So the new angles are acute since they have to be less than 90. Alright, so we were given the following formula for a sequence. Let's actually, instead of w, let's change this to f of n, use that function notation we've been seeing. Let's write the sequence, determine whether you used induction or deductive reasoning. So n, if we look at this hint, stands for the term number. Always start with n equals 1 for the sequence. So if I'm looking for f of 1, I'd plug in 1 for n. So my f of 1 here would equal 4.75. I do the same thing, find the next one, f of 2. So f of 2 would equal 4.5. Okay, so my sequence would start with 4.75, be going down by 0.25 each time. Okay, did we use induction or deduction? We use deductive reasoning when we're following these rules. That's our proof for why that's our sequence. In a linear pair, one angle must be acute. Determine whether or not this statement is true. If it is true, explain how you know that. If it's false, give a counterexample to prove your point. Also determine whether you used inductive or deductive reasoning. Okay, so my linear pairs, two angles that form a right line, a straight line. So here we can see we have an acute angle. Again, here would be an acute angle. But I could also draw the other ray of the arrow perpendicular. So right angles are not acute, so this would be false. And again, we use deductive reasoning. We have proof that explains our conjecture. Okay, so again, to summarize the big difference here, inductive reasoning allows you to discover new ideas based on observed patterns. Deductive reasoning can help explain why your conjectures are true. These two types of reasoning work very well together. In an investigation, you will use inductive reasoning to form a conjecture and deductive reasoning to explain why it's true.